Every year, crop diseases silently devastate the world's food supply, costing the global agricultural economy an estimated $220 billion in losses annually. That staggering number is not just a financial figure. It represents empty plates, collapsed livelihoods, and deepening hunger crises across continents. For farmers, especially those in developing regions across sub-Saharan Africa, South Asia, and Latin America, the challenge is painfully real. Most lack access to the expertise needed to identify diseases early enough to stop the spread. By the time visible damage appears, entire harvests can already be beyond saving. But something remarkable is beginning to change this story. Artificial intelligence is stepping into the fields, quite literally, offering farmers something they have never had before: fast, accurate, and affordable disease detection. This is how technology is rewriting the future of farming. For generations, farmers have relied on a handful of methods to detect crop diseases. The most common approach involved calling in agricultural experts for visual inspection, walking through fields to spot unusual discoloration, wilting, or lesions. Others turned to laboratory testing, sending plant samples for analysis, or consulting agricultural extension officers for guidance. While these methods have served their purpose, they come with serious drawbacks. Hiring specialists is expensive, often beyond the reach of smallholder farmers. Laboratory results can take days or even weeks to return. Extension officers are frequently stretched thin, covering vast areas with limited time for each farm. Perhaps most critically, by the time a disease is officially confirmed through these traditional channels, it has often already spread across significant portions of the field. What began as a manageable problem becomes a devastating loss, costing farmers their entire season's income. So how exactly does artificial intelligence step in to solve this problem? It all comes down to machine learning and deep learning, two branches of AI that are transforming how we detect crop diseases. Think of it like teaching a child to recognize different animals by showing them thousands of pictures. Scientists feed AI systems hundreds of thousands of images of both healthy and diseased plants, covering conditions like blight, rust, mildew, and bacterial infections across dozens of crop varieties. Over time, the system begins identifying subtle visual patterns, tiny color changes, unusual spots, or texture differences that even trained human eyes might miss. What makes this truly remarkable is the speed and scale. Once trained, these models can analyze an image and deliver a diagnosis in seconds, often matching or outperforming agricultural experts who have spent decades in the field. This is precision agriculture at its most powerful. At the heart of AI crop disease detection is computer vision, a technology that enables machines to interpret and analyze visual information just like the human eye, but far more precisely. AI-powered cameras and smartphone applications can now scan leaves, stems, and fruits in real time, identifying visual symptoms such as discoloration, lesions, spots, and wilting that signal disease. The real engine behind this capability is convolutional neural networks, a specialized type of deep learning architecture designed specifically for image analysis. These networks process images layer by layer, with each layer extracting increasingly detailed features, starting from basic edges and colors, then moving toward complex patterns and textures. By the time the image reaches the final layers, the system has identified specific disease markers with remarkable precision. This layered processing makes detection both incredibly fast, often within seconds, and highly accurate, sometimes outperforming even trained agricultural scientists. Some of the most exciting real-world applications are already changing lives on the ground. The Plant Village project, developed by Penn State University, has built a massive database of crop disease images and trained AI models to diagnose over 50 plant diseases with remarkable accuracy. Their technology has been deployed across multiple African nations, putting expert-level diagnosis directly into farmers' hands. Apps like Plantix take this even further, allowing farmers to simply photograph a diseased leaf with their smartphone and receive an instant diagnosis, along with treatment recommendations within seconds. No laboratory, no waiting, no expensive consultant required. What makes these tools truly revolutionary is their accessibility. A smallholder farmer in rural Kenya, a rice grower in Bangladesh, or a maize farmer in rural Colombia can now access the same quality of agricultural expertise previously reserved for large commercial operations. These platforms are genuinely democratizing agricultural knowledge at an unprecedented scale, but AI's capabilities extend far beyond simply analyzing a single photograph. Today's most advanced agricultural AI systems integrate multiple data streams simultaneously to build a complete picture of crop health. Drone imagery captures field-wide patterns invisible from ground level, while satellite data monitors vegetation stress across entire regions. Soil sensors measure nutrient levels and moisture content, and weather station networks track temperature, humidity, and rainfall patterns in real time. When combined, these data sources feed into sophisticated predictive models that can forecast disease outbreaks before a single visible symptom appears on any plant. By analyzing historical outbreak patterns alongside current environmental conditions, AI can calculate disease risk probabilities days or even weeks in advance. This predictive capability is genuinely revolutionary. Instead of reacting to disease after damage occurs, farmers now receive advance warnings, creating a critical intervention window where preventive treatments can be applied strategically, protecting yields before any real threat materializes. Beyond satellites and drones, the revolution is also happening right at ground level. Internet of Things devices and connected sensors are now being deployed directly throughout agricultural fields, quietly working around the clock to monitor the environmental conditions that silently trigger crop diseases. These small but powerful devices continuously track humidity levels, air and soil temperature, leaf wetness, and wind patterns, all of which are well-documented precursors to dangerous fungal and bacterial outbreaks. When humidity spikes after rainfall or leaf surfaces remain wet for extended periods, conditions become ideal for pathogens like late blight or powdery mildew to spread rapidly. This is where artificial intelligence becomes truly powerful. AI systems process this constant incoming data stream in real time, cross-referencing sensor readings against disease risk models built from years of agricultural research. When conditions align with known outbreak patterns, the system immediately sends targeted early warning alerts directly to farmers through their mobile phones, giving them precious time to intervene before infection takes hold. One of the most powerful benefits of AI disease detection is its ability to transform how farmers use pesticides. Traditionally, farmers would blanket spray entire fields as a precaution, regardless of whether every plant was actually affected. This approach wasted resources and caused serious environmental harm. With AI-powered detection, farmers now know exactly which zones show signs of disease, allowing them to apply treatments only where and when they are truly needed. This targeted strategy dramatically reduces the volume of chemicals entering the soil and waterways. For farmers, the financial savings are substantial, as pesticide costs can consume a significant portion of their annual budget. Beyond economics, reduced chemical use means healthier ecosystems, with pollinators like bees and natural predators recovering in treated areas. Biodiversity improves, soil health strengthens, and agriculture moves meaningfully closer to sustainable, environmentally responsible practices that can support food production for generations to come. To understand the real power of this technology, consider Samuel, a smallholder maize farmer in rural Kenya. In 2022, Samuel noticed unusual yellowing on a few plants, but assumed it was simply a nutrient deficiency. Using the Plantix application on his basic smartphone, he photographed the affected leaves. Within seconds, the AI identified early-stage maize lethal necrosis disease, a devastating condition that spreads rapidly and can destroy entire harvests within weeks. Armed with this diagnosis, Samuel contacted his local agricultural cooperative, obtained the appropriate treatment, and applied it precisely to the affected rows before the disease could spread further. He saved nearly 80% of his harvest that season. Without that AI-powered diagnosis, Samuel estimated he would have lost everything, pushing his family into serious financial hardship. Stories like his are multiplying across Africa, Asia, and Latin America, proving that artificial intelligence is not just a technological marvel, but a genuine lifeline. Despite its remarkable promise, AI-powered crop disease detection still faces significant hurdles that cannot be ignored. Training accurate models requires enormous, diverse datasets representing countless crop varieties, disease strains, and regional growing conditions, which remain difficult and expensive to compile comprehensively. Connectivity poses another serious barrier. Many rural farming communities lack reliable internet access, making cloud-based AI tools practically unusable precisely where they are needed most. The digital literacy gap among older farming generations further complicates adoption. Many experienced farmers feel uncomfortable navigating smartphone applications or trusting algorithmic recommendations over decades of personal knowledge. Perhaps most critically, there is a growing concern about over-reliance on technology. When farmers follow AI recommendations without understanding the underlying reasoning, they become vulnerable when systems make errors or encounter unfamiliar disease patterns. Fortunately, researchers, governments, and technology companies are actively addressing each of these challenges, developing offline-capable tools, simplified interfaces, and comprehensive farmer training programs to bridge these critical gaps. Despite the challenges, the future of AI and crop disease detection looks extraordinarily promising. Hyperspectral imaging is one of the most exciting frontiers, capable of detecting diseases invisible to the naked eye by analyzing hundreds of light wavelengths beyond what human vision can perceive. This means infections can be identified days or even weeks before visible symptoms emerge. Next-generation AI models are being developed to simultaneously identify multiple diseases within a single scan, dramatically improving diagnostic efficiency. Rather than detecting one problem at a time, these systems will deliver comprehensive crop health reports instantly. Perhaps most revolutionary is the integration of genomic data. By combining a crop's genetic profile with environmental and disease data, AI can predict which varieties are most vulnerable before an outbreak even begins. The near future envisions disease management that is fully automated, deeply proactive, and uniquely personalized to every individual farm, transforming agriculture from reactive to genuinely predictive. The journey of AI in crop disease detection is ultimately a story about people. It is about the smallholder farmer in Kenya protecting her maize harvest, the rice grower in Bangladesh catching blight before it spreads, and the tomato farmer in Peru saving an entire season's income. AI is not here to replace the wisdom, instinct, and dedication farmers bring to their land. It is here to stand beside them as a powerful, intelligent partner. But technology alone cannot drive this transformation. We need governments to fund AI agricultural research and create policies that bring these tools to developing regions. We need tech innovators to sit with farming communities, listen, and build solutions that truly serve them. The future of food security depends on collaboration, investment, and shared purpose. Together, we can build an agricultural world that is smarter, stronger, and more resilient for every generation to come.